Okay, for today's homework, I'm going to have you get the 3 points from these triangles. I'm going to have you use a distance formula for all 3 sides, and then I'll have you plug in the sides into the Pythagorean theorem. So here we go. First problem, those points for that triangle, I am going to call that triangle 0, 3, negative 2, 3, and negative 2, 4. Those make up the 3 vertices of that triangle. So A is 0, 3, B is negative 2, 3, and C is negative 2, 4. I need to find all 3 lengths. I'm going to do AB first. So that's going to be 0 taken away 2 becomes 0 plus 2 squared plus 3 minus 3 squared. Again, left to right, knowing that if you're subtracting a negative, that's a double negative. That gives me 2 squared plus 0 squared, which gives me the square root of 4. For these problems, leave the radical alone until the check is done. BC, negative 2 subtracting a negative 2 is negative 2 plus 2 squared plus the y numbers 3 minus 4. That gives me the square root of 0 squared plus negative 1 squared, which just gives me the square root of 1 squared, which is the square root of 1. Leave the radical until the proof is done. AC, the last two. 0 taken away negative 2 is 0 plus 2 squared plus the y numbers for A and C. 3 minus 4 gives me 3 minus 4, negative 1 squared. That gives me 2 squared plus negative 1 squared, which gives me 4 plus 1, which gives me 5. Now when I'm looking at these, this is clearly the biggest length of all 3. This will be the hypotenuse number. These 2 are the smaller. These are the legs. So when I plug them in, the 2 legs will go into the Pythagorean theorem together. The a squared plus b squared part will be root 4 squared plus the square root of 1 squared, and see if that equals the longest side, the hypotenuse, root 5 squared. Remember, squaring something square rooted cancels away. That is an inverse operation and just leaves me the whole number 4. So that when I plug that in, I get 4 plus 1 equal 5. And 5 does equal 5. Yes, that is a true statement. That proves those points make up a right triangle. All right, next problem. All right, for this one, again, I'm going to label the 3 points of that triangle. So that will be A, that will be B, and that will be C. It looks like A is the point 3, negative 5. 3 for x, negative 5 for y. B is 3, 0, 3 for x, 0 for y. And C is negative 2 for x, 0 for y, negative 2, 0. That is C. I'm going to find all 3 lengths. So I'm going to do AB first. When I do A and B, that gives me 3 minus 3, the x numbers together, 3 minus 3 squared plus negative 5 minus 0 squared gives me 0 squared plus negative 5 squared, which gives me the square root of 25. Again, leave the radical alone before you do the check. I'm going to do A and B. Oh, I'm sorry, AC this time. So 3 all the way down. 3 taken away that negative 2 becomes 3 plus 2 squared plus negative 5 minus 0 squared gives me 5 squared plus negative 5 squared, which gives me the square root of 25 plus 25. And again, leave that radical alone. Leave that root 50 alone. All right, now I need to do B and C. So BC. That gives me 3, taking away that negative 2. 3 minus minus 2 becomes 3 plus 2 squared, plus 0 minus 0 squared. Gives me the square root of 5 squared, which is root 25. Again, leave that radical alone. This by far is the largest length. That is the hypotenuse. These two are the smaller sides. These are the legs. So I'm going to put root 25 and root 25 into A and B and plug this into C in the hypotenuse spot. So root 25 squared plus root 25 squared. Will that equal root 50 squared? If that is, that proves that is a right triangle. Remember, square rooting something square, those are inverse operations, and just leave me 25 plus 25 equal 50. That is a true statement. Make sure you write yes. I will write yes at the end. Yes, that is a true statement. You got to tell me yes or no to get full credit. All right, last problem. For this one, again, label those points. It looks like A, B, C. Looks like A is going to be 1 for x, negative 2 for y. B is going to be negative 5 for x, negative 2 for y. And C is going to be negative 5, 5 for y. Make sure you know how to write coordinates. So negative 1, or 1, negative 2, negative 5, negative 2, that is B. And then C is negative 5, 5. So again, I'm going to find all three lengths. I'm going to do A, B first. So that's going to be 1 taking away that negative 5. 1 minus minus 5 is 1 plus 5 squared. Again, subtracting my x numbers. Negative 2 taking away something negative is negative 2 plus 2 squared. This gives me on the radical 6 squared plus 0 squared equals the square root of 36. Leave that radical alone. The next length I do here is B and C. So negative 5 minus minus 5 is negative 5 plus 5 squared plus negative 2 minus 5 squared gives me 0 squared plus negative 7 squared, which gives me the square root of 49. Leave that alone. Now the next one is AC all the way down. So that's going to be 1 taken away minus 5. So 1 minus minus 5 is 1 plus 5 squared plus negative 2 minus 5 squared, the two y numbers. That gives me the square root of 6 squared plus negative 7 squared. Gives me the square root of 36 plus 49. And that gives me the square root of, checking my arithmetic. So 36 plus 49, don't take a chance with the arithmetic. 6 plus 9 is 15, carry the 1. 7 plus 1 is 8. That gives me root 85. Again, this is by far the hypotenuse, the longest of the three sides. These two are smaller. They are the legs. They will go together. So my proof, plugging in these legs into the Pythagorean theorem gives me root 36 squared plus root 49 squared equals the square root of 85 squared. Remember, square rooting something already squared or squaring something already rooted cancels away and just gives me 36 plus 49 equals 85. And that is a true statement. Yes, make sure you write yes. That is a true statement. And I'm going to go down here and finish this up by writing yes. That is a true statement. Yes, that is a right triangle. All right. Good luck with your homework. I'm here every day at lunch or break. Everything at this point can be made up for full credit.